This video is for the Inequalities and Absolute Values module. In this video we are looking at section IEAB-C. Firstly, there are rules for solving inequalities. Now the principles for solving inequalities are similar to those used when solving equations, so just like you did in the SAL module. The purpose of solving an inequality is to determine the range of values that the variable can take. Now to achieve this purpose, the unknown variable needs to be isolated on one side of the problem. It needs to be on its own. Values must therefore be moved away from the variable across the inequality symbol by performing the opposite operation to both sides of the inequality. Now you must be careful when inequalities are involved because there are special rules that may need to be applied when isolating the unknown. Now these special rules are as follows. The inequality will remain the same, so going in the same direction, when a number is added or subtracted to both sides of the inequality, or when both sides of the inequality are multiplied or divided by a positive number. Okay, now the direction of the inequality is reversed if both sides are multiplied or divided by a negative number. Okay, so this is really important. This is where things are different to equations. If you're multiplying or dividing by a negative number, your inequality sign, the direction will change. So let's look at some examples. X plus 4 is less than 12. Now to isolate that plus 4, I take 4 from both sides. So x is less than 12, take 4 is 8. And that is my solution. X take 4 is greater than or equal to 12. To isolate that x, I'm going to add 4 to both sides. So x is greater than or equal to 16. Next, 4x is less than or equal to 12. X is being multiplied by 4, so we divide by 4. So x is less than or equal to 12 divided by 4 is 3. Next, x is being divided by 4, so we're going to multiply both sides by 4. So x is less than or equal to 12 times 4 is 48. Now remember, you can check these, okay? So just for example, if I was to check this one here, x is less than 8. So if I pick 6, okay, and I plug it into x plus 4, that would be 6 plus 4, which is 10. And 10 is less than 12. So that works. Okay, now let's look at ones where special rules apply. The first one is negative 4x is less than or equal to 12. Now that x is being multiplied by negative 4, so we're going to divide by negative 4. Now because we're dividing by a negative, that inequality sign has to change direction, so it becomes greater than or equal to. So now I have x is greater than or equal to 12 divided by negative 4 is negative 3. Okay, next one, negative x over 4. Now remember, negative x over 4 is the same as negative x over 4, which is the same as x over negative 4. They're all the same thing, okay? But we usually write it such that the negative belongs to the whole fraction. So to get rid of that negative 4, I'm going to multiply both sides of the equation by negative 4. So that means that inequality has to change direction. It needs to become a less than. So now I have x is less than 12 times negative 4 is negative 48. Okay? And again, it's a good idea to do a quick check. So in this one over here, I have negative 4x is less than or equal to 12, and I found that x is greater than or equal to negative 3. So if I picked x as 0, which is greater than or equal to negative 3, and plug it in, I get negative 4 times 0, this is for my left hand side, which is 0, and that is less than or equal to 12, so that works. Now solving multi-operation inequalities. When solving multi-operation inequalities, just means you're going to be doing more than one step. Eliminate fractions by multiplying all terms by the common denominator. Eliminate brackets by expanding using the distributive law. Isolate variable terms by moving variable terms to one side of the inequality symbol. Move constant terms to the other side. Divide variable by variable coefficient. Change the direction of the inequality of dividing by a negative number. Okay. So let's look at some examples. The first one is 3x minus 2 is greater than or equal to 13. So to isolate the x, just like we did in equations, we need to get rid of that negative 2. So I'm going to add 2 to both sides. So I have 3x, negative 2 plus 2 is gone. It's greater than or equal to 13 plus 2 is 15. Okay. X is being multiplied by 3. So I divide by 3. So x is greater than or equal to 5. Again, you can do a check. In the next one, we have unknowns on both sides of the equation. Okay, so I have to decide what I'm going to get to one side, what I'm going to get to the other. Here I have a negative 5x, and here I have a 2x. Okay, so the x's are positive over this side, so I'm going to leave the x on the right hand side. Okay, so if my x's are staying on my right hand side, I'm going to have my numbers on my left hand side. Okay, so let's start doing that. I've got 10 minus 5x is less than 2x minus 11. That's going to stay and that's going to stay. So to get rid of this negative 5x, I'm going to add 5x to both sides. Okay, to get rid of this negative 11, I'm going to plus 11 to both sides. So I have 10 plus 11 is 21. Negative 5x plus 5x is 0, is less than 5x plus 2x is 7x. X is being multiplied by 7, so I divide by 7. So I have 3 is less than x, or I can write it as x is greater than 3. Okay. In the next one, I have a bracket, so let's get rid of that first. 5 times x, 5x. 5 times negative 2 is negative 10. That's less than or equal to 3x minus 7. Okay, pick which side you want things to stay. If I take 5x from both sides, this is going to become a negative. So my higher x is over here, so that's where I'm going to leave it. So that means my constant's going to be going to that side. Okay, so I need to get rid of this minus 10, so I add 10 to both sides. I need to get rid of the 3x, so I'm going to minus 3x from both sides. So 5x minus 3x is 2x. It's less than or equal to negative 7 plus 10 is 3. Okay, and now I need to divide both sides by 2 because x is being multiplied by 2. So that means x is less than or equal to 3 over 2. And we can leave it as an improper fraction. That's what we normally do in algebra. Or you can have x is less than or equal to 1.5. Okay? And again, remember you can check your solutions. The checking is shown in the textbook if you'd like to have a look. What now? Well, you need to practice. So complete exercise IEAB C1 from the textbook. If you don't understand something, you might want to re-look at this video. Ask the course coordinator for help if you really don't understand.